All right, we're looking at an introduction here to factoring. So we're going to get into factoring quadratics. Now just a quick review. Factors are things, right? We're breaking something into smaller pieces, whether it's a number or a polynomial. So factors of a number, for example, are simply numbers that can be multiplied together to make that number. Okay, and they can involve positive, negative numbers. Of course, they could even contain variables if we had some kind of expression with variables in it. So again, really basic example, the factors of 6. So we're looking, hey, what numbers can multiply to make 6? Well, 1 and 6, 2 and 3, right? Not very many. You could also have -1, -6, -2, -3. Factors of -12. You can see the list there, all right? So factoring, I want you to feel good about, is the opposite of distributing. So when we distribute, we multiply something through. When we factor, we're dividing something out. So when we factor a polynomial, we're dividing it into smaller pieces. To help us factor polynomials, first thing always I encourage you to do, look for any common factors each term shares. Try to divide that out, the biggest factor you can. We call it the greatest common factor, and this probably sounds familiar to you. Now, one good thing about factoring here in bold, you can always check to see if you did it right by distributing your answer and see if it matches the original problem. Okay, let's go look at some examples. So, factor each of the following expressions. Okay, now each of these, we're just looking for the greatest common factor. So what does this term and this term have in common? Well, notice no variables here, and so 3. Well, I can't divide anything bigger than a 3 out. Well, 9, you can also take a 3 out. So this would be the same as 3 times x squared plus 3. Now again, notice how I could check myself. If I multiplied that 3 through, I should get the same thing I started with, 3x squared plus 9. Hey, that's not too bad. How about in this? What can I take out? Again, no variable over here to worry about. 25 and 35, what factor would they have in common? What's the biggest number I could divide out of both? Well, I could take a 5 out of both of those. So if I pulled a 5 out, that would leave 5x squared minus 7. Notice again, if I multiplied the 5 through, I would be right back where I started. How about here? Oh, they have an x in common. So if I factored x out, that would leave x minus 2. Again, x times x, x squared, x minus 2, or times -2, -2x. And very similar here, right? I could take an x out. So x times 5x plus 7. Hey, that's GCFs, that's basic factoring, not bad. Okay, what if we expand a little bit? We're going to look at trinomials now. Now, I kind of like to introduce this. Let's just review something from the past. How would I multiply this out? Well, you distribute, right? Sometimes the textbooks use FOIL. I'm not a huge fan of that, because sometimes it confuses kids. It's just distributive property. So x times x is x squared. X times 4 is 4x. Now let's take the 3 through. So we get 3x plus 12. And then of course we could simplify. These middle terms are going to go together, right? They're like terms. So 7x plus 12. Well, factoring is just the reverse of that. We're going to start with a problem that looks like this, and we're going to turn it into something that looks like this. So notice x plus 3, x plus 4 are factors of x squared plus 7x plus 12. Now, here's the key for today, and the lesson's long, but I'll sum it up here pretty quickly. To factor a polynomial that looks like this, x squared plus bx plus c. Now notice no a here, we're only dealing with ones today. Look for two factors of c, so two numbers that multiply to make c, that add to make b. That's how you factor, okay? Now the signs of b and c can be negative, right? You could have negatives in here, one or other, or both. So if they are, we still look for factors of this number that add to make b, but you need to recognize one or both is going to be negative. That's the only difference, okay? So let me look at some examples with you, and I'm going to come up with these factors pretty quickly because I've factored a ton in my life. I've got a lot more experience than you do. So don't stress about it. It takes practice to do these. But I'll illustrate the point, okay? I'll illustrate how you do this. Factor each of the following. So x squared plus 15x plus 36. First thing I look for, none of these will have any by the way, but is there something I could factor out of the whole thing? I would always look for that first, okay? Now, I want two numbers that multiply to make 36, that add to make 15. And if it helps, especially when you start listing factors of 36. Sometimes you'll come up with it pretty easily, sometimes not. 2 and 18, 3 and 12, 4 and 9, 6 and 6. That's basically all of them, right? And again, if you're not sure where to get those from, well, just start dividing 36. 36 divided by 2, 36 divided by 3, 36 divided by 4, 36 divided by 6. Especially if they're bigger numbers you're not as familiar with. Well, do you see anything there that's going to add to make 15? Hey, 3 and 12, right? And so I'm going to do x plus 3 and x plus 12. There is my factored expression. Now notice, if I multiplied this out, x times x is x squared, x times 12 is 12x, 3 times x is 3x, 12x plus 3x is 15x, that's where that comes from, and 3 times 12 is 36. Hey, that's how you factor a trinomial, okay? How about this one? Now these other ones have some negative signs. Factors of negative 20 that add to make positive 1. So because this is negative, I know my two numbers are going to have to be opposite. Again, maybe just list them out, especially when you're first starting. 4 and 5, that's it, right? So now I know one's got to be positive, one's got to be negative, and they have to add to make 1. Well, these have a difference of 1. So positive 5 and negative 4 would multiply to make negative 20, and they would add to make 1. So now I'm going to list my factors. So x minus 4, x plus 5. Do you see how I'm doing that? Does that feel kind of familiar? How about this guy? Now this is kind of, oh, I wrote the same problem twice in a row. Sorry about that. Let me just illustrate. What if we did something different? What if I made a negative here and had this number be negative? Let's leave it, okay? Can you see the difference? Well, still need to multiply to make negative 20, but need to subtract. Now I need a negative 1 out of that. And so that in that case it's going to be a negative 5, right? And a positive 4. I just switched my signs. So this one would be x minus 5 and x plus 4. And by the way, it doesn't matter the order you write these in, because when you multiply them, right, 2 times 3 is the same as 3 times 2. So I'm just writing these kind of the order that pops up to me. But if I wrote x plus 4 first, it doesn't matter. It's the same thing, okay? Now how about this one? So factors of negative 14 that add to make negative 5. Well, 14 doesn't have very many factors. 1 and 14, 2 and 7, right? So they've got to be opposite to multiply to make a negative, but they have to add to make negative 5. So I want that 7, the bigger number, to be negative, 2 to be positive. So x plus 2 and x minus 7 are going to make it happen for me. Okay? So again, I know that's a quick introduction. You've seen factoring in Algebra 1, I'm sure, but a quick overview. So work your way through the lesson. It's got lots and lots of examples. It's good. It takes practice to go through things, and hopefully it'll go well for you.